Hey guys, so I got a test here going with one of these AGMs. Here's the input, 125-ish milliamps at about 16.8 volts when it's full, straight full. So I just started this up, got it tuned up a bit. It's under a pretty good load. That coil back there is hooked to this light bulb, and it's a high voltage coil, so it pretty much has a short on that, and it's turned, the motor's turned down as low as I can turn it here. Can't go any slower. It can't use any less current unless the voltage in this cap bank increases. Then the RPMs drop and the current goes down as the voltage in the cap bank goes up. It will go up as the battery charges. So, and I've got one of my Mosfet dump circuits on here. It's dumping about 2 amps every, I don't know, 10 seconds or so. They were counted. At about 10 seconds, it dumps 2 amps into the battery. Yeah, these circuits are great because they're on and they're off right away. It's not like a SCR that latches. What the SCR does is it fires pretty quick, and then it stays on till the cap bank reaches the battery voltage, and then you can watch it unlatch and it'll go back up. And another problem with the SCR is if you're like on this motor, if I try to run it about 200 or 300 milliamps with this big cap bank, then it just latches and stays on. So it's not very good for this type of stuff. These circuits here can be fine tuned, and yeah, they work really good if you got patience, because it does take patience to tune them up. See, like what happens here with this one is this cap bank here is parallel to the output of the motor, which is nice about these circuits. How I made them is it's paralleled with that cap like that, because the input goes directly to the cap, and then it feeds the circuit here, which fires the MOSFETs. And these are 120 amp MOSFETs, each one of them. And the 220 package. So they're small, but I've never blown one up actually. They're not a fast firing MOSFET for like running a motor. They're not very good, but for these cap dumps, they work awesome. And I can increase the duty cycle too. Like I can make it stay on and dump more of the cap bank out if I want to. But what tends to happen with these is if you just leave the voltage rise in the cap bank, it'll dump more current into there, which like in turn it regulates itself, because like you'll see as the voltage in the cap bank rises, the input current will go down and the rotor will slow down a little bit because it's fighting that back spike which is in the coil. But they usually just regulate themselves out and you don't have to screw with it too much. So I've discharged 4 amp hours out of that battery. These ones hold 6.8 amp hours. Probably a little more because I think I did that discharge test with half an amp. Or no. It was either 300 milliamps or half an amp I did that discharge test with, and I got 6,800 milliamp hours out. But you know, like this is a 16.8 volt battery when it's fully charged, so 4 amp hours isn't equal to 4 amp hours in this battery. So really you'd have to use like 3 amp hours to put 4 in there for an equal test, right? And what I've been seeing too with this pulse charging, with the discharge tests I do after your constant current discharge test, is there's hardly any power in the batteries compared to when I just run it continuous, like a normal charge. Yeah, the power in the batteries is pathetic when you pulse charge it. That's really hardly anything in there. And that was with SCRs, though. I'm going to try it with this circuit. But it does tend to take some of the sulfation off if you have a battery. Like these batteries are in really good shape, so I don't have any problems with sulfation. Like, I got no shortage of batteries around here. Like this type of circuit here works really good because it's dumping a lot of current. Every time those lights come on, it's dumping over 30 amps into these batteries here. I've got a lot of these batteries. They're deep cycle golf cart batteries. I just bring them once in a while, give them a charge like this, a regular charge, and then I'll cycle them quite a bit because these are lead antimony batteries and they have to be cycled. I like to do it at least once a year when I get time. This is something I do. And that's how you keep them in good shape. And make sure you use one of these. If you don't use one of these, your batteries are not going to last. And that thing tells you the whole truth about what's going on with your batteries. These are lead calcium chemistry, and they suck for deep cycling. They're not made for deep cycling. I don't care what people say about AGMs. Lead calcium batteries are only good for like a UPS, where they can stay on a float for years at a time, and then when they're needed, they perform. But cycling them, they're no good. You need to do proper tests. What I do is I have these. I've got a bunch of these always on the shelf. No acid in them. They're brand new. Lead antimony construction. Here's the acid for you know, when I have time, I do tests with this type of stuff. I don't know. I've watched all those tests with Bedini when he tried to get his motor verified by the engineers in the early 2001 or so. I can't remember what year it was. And the way those guys did those tests was crazy. Like, for one thing, you shouldn't do it with batteries that you've bought from the store, because you don't know how long those batteries have been on the shelf. They could be sulfated right from the start. The only way you can do it is if you put the acid in the battery right off the bat and do it like that. And the results from what he got was definitely not over Unity. Hey guys, sorry my phone ran out of memory there. I was just on a little rant about Bedini. No, they did that test. If you guys haven't seen that series of when they did try to do that validation of the Bedini motor with the cap dump circuit with that German engineer, you should watch it. You can catch Bedini in a lot of lies with that whole thing. Like, there's that one video where he's actually talking about that test, and he's trying to say that all his batteries got up to 13.3 volts and they called them charged. Well, that never happened. You can watch the whole test. It never happened like that, unless there was a different test. I don't know, but the pictures and stuff he shows is from the test, that with the video, the series of them testing that one. So I don't know what to believe when you hear that from him. And like, they chose those really small batteries because they were trying to do their test in one day, like during the daylight hours, instead of leaving stuff run, or actually having two engineers there doing a night shift like it should have been done with larger batteries. And the way they were discharging and charging the batteries was totally crazy. Like, they could have used bigger batteries and had a constant current supply and discharger like I have. I have 3 of those, and I can graph everything out. And the only reason that engineer said he didn't bring it was too big to bring on the plane. So I don't know why they got German engineers when they could have got some from America. But just a rant. Sorry about that. Just had to say my opinion about that, because I don't know, I had a lot of experience with batteries. I've been running my house off grid for quite a while. Most of it anyway. Big part of it. But I will have a discharge curve of this after this is charged. After I'm done this test, I will show a discharge curve. I usually pull an amp continuous because it's 12 amp hour battery at a 10 hour rate, so should be able to pull 1.2 amps for 10 hours at that rate. So, been a long video, but thanks for watching, guys.